Hello viewers, I am Kausalya. Today we are going to discuss about an introduction to electric circuit theory. So whenever we hear the name circuits, the most common things that comes in our mind is voltage, current, power, energy, etc. Right. So to start with, we are going to discuss about current first. So here the symbol of current is I. So, the basic thing is, as we all know, an atom has protons, electrons, and neutrons. And protons are positively charged, and electrons are negatively charged, and neutrons are neutral charges. And here, protons and neutrons are present inside the nucleus, whereas electrons they revolve around the center of the nucleus. That is, electrons are the free elements that can move around, right? And these free electrons are found to be more in number in semiconductors and conductors, right? So these are all the things which we are quite familiar, right? So semiconductors and conductors have more number of free electrons. For example, consider this as a conductor, and this conductor has some electrons like this. And when no supply is given, when no voltage is given, these free electrons they move randomly, right? That is, some electrons tend to move to the right side of the conductor, and some electrons tend to move to the left side of the conductor, right? When no supply is given, the electrons which are present in the conductors or semiconductors they move randomly. And when supply or voltage is given, what happens here, these electrons, okay, they tend to align and they start moving in a particular direction, right? And this movement of electrons from one end of the conductor to the other end constitutes the current, right? That is, movement of electrons produces current, and current is defined as rate of flow of electrons, right? That is, only the flow of electrons gives us current, therefore it is defined as the rate of flow of electrons. So I is written as q by t, right? And q represents the charge of electrons and t is the time taken. And similarly, this same current I can be written as dq by dt. Here dq is nothing but small change in the charge with respect to small change in the time. Okay. The next topic is voltage. Voltage is otherwise known as potential difference, right? So here, as we all know, an atom has positive and negative charges, right? So what happens between a positive and negative charge? There exists a force of attraction, right? So certain amount of work is required to overcome the force and move the charges through a specific distance. That is, one is with a positive charge and another one is with a negative charge. So what happens here? Due to the force of attraction, they attract each other, right? But here certain amount of work is done. Some work is done to separate these two charges, right? So after work is done, you see the charges get separated like this. So here all opposite charges possess a certain amount of potential energy because of the separation between them. That is, since the charges are separated by a distance, these two charges possess some potential energy, right? So the difference in potential energy of the charges is called potential difference, right? That is, the positive charge will have some potential energy and negative charge will have some potential energy. So the difference in potential energy of the charges gives the potential difference, right? And here the voltage is represented by V is equal to W by Q. In other words, V is equal to dW by dQ. That is small change in the difference in potential energy with respect to the charges. And here the unit of voltage is nothing but volts, and 1 volt can be represented as 1 joule by 1 coulomb, right? Now the next topic is power and energy. So as we all know, energy is the capacity for doing work, right? So energy is the most common term which we are using in our day-to-day life also. So energy is nothing but it is the capacity of doing some work. So energy exists in the form of, technically speaking, what are all the different types of energy? Here we are having, you see, electrical, mechanical, chemical, etc., etc. It goes on. Right, there are many forms of energy. And the next thing is power. Power is nothing but rate of change of energy. That is, change of energy with respect to time is known as power. So power is given by energy by time. Right. That is change of energy with respect to time. So it is represented by W by T here, or simply we can write it as P is equal to dW by dt. Here dW is nothing but change in energy and dt is nothing but change in time. Right. And here that is P is equal to dW by dt. This dW by dt can be written as dW by dq into dq by dt. Right. Because again you see this dq cancels each other and finally we will be having this dW by dt. Right. So we are just reframing like this. So dW by dq is nothing but V and dq by dt is nothing but our I. Right. Therefore P is nothing but V into I. The next topic is circuit. So whenever you hear the name circuit, the picture that comes in our mind is there will be some current or voltage supply and there will be some load which is connected to it. Right. So the same way here, the circuit has three important parts. One is energy source and another one is load. Right. And to connect this source and load, there will be some wires or connectors. Right. So a circuit has three basic elements. So here you see, this is the typical example of a circuit. Right. So the first thing is energy source. What do you mean by energy source? That is, this is the, here as the name is given, source. Okay, this is the thing which gives power to the circuit, which gives energy to the circuit. Right. So the examples are generators, as we all know, right? Even during power cuts, we will turn on the generators, right? So generator is a form of energy source. And the next one is battery. Right, here in our day-to-day life, we are using UPS, right? So UPS has battery. So they are known as energy sources. In other words, they are known as active elements. Right. So in this diagram, here I had drawn a battery. Right. So here the battery is an energy source. And the next thing is load. Right. Load is nothing but load. Again, load are of different types. Okay, resistive load, inductive load, RLC load. There are many types. But here simply we are considering a lamp here. Right. Lamp is a resistive load. So here lamp, it is a, in other words, they are known as passive elements. Right. Passive elements are those that dissipate energy. Okay, they receive, okay, they accept the energy. And active elements are those they produce. Okay, they are the main element in a circuit. Only when they are active, they give supply to the rest of the circuits. So they are known as passive elements here. And the third one is known as, you just see, here we are having a battery and here we are having a lamp. Then in order to connect the source and the load, there should be some wires, and technically speaking, they are known as connectors. Right. Connectors, or even we can tell them as conductors also. So this is our basic circuit. The next topic is electrical resistance and resistivity. So here resistance is nothing but it is a property of a circuit that opposes the flow of current. Right. In other words, resistance in a circuit is the parameter which dissipates the energy. Right. Which dissipates energy is, it dissipates energy in the form of heat. Right. So resistance is nothing but it opposes the flow of current through it. That is the first thing. Since it is opposing the flow of current through it, it dissipates heat. Okay, it dissipates energy in the form of heat. And here the unit of resistance is ohm. Right, the symbol, it is generally denoted as R, and the resistance unit is ohm. It is denoted by this symbol. And the amount of current passing through the conductor right? Because only through the conductors we are connecting our load and source. So the current passing through the conductor, it depends not only upon the impressed voltage, that is not only on the supply voltage, but it also depends upon the properties of the conductor, right? Because here you see we are having a load, and to this load we are connecting a battery, right? So here supply is given like this. So here current flows. So in this case you see the current, okay, the value of current that flows in a circuit, it not only depends upon the supply voltage here, it also depends upon this conductor parameters. So what are all the different parameters of this conductor? Just now consider a wire, okay? So what are all the things you observe in a wire? So the first thing is material of the conductor, right? So conductors are made up of different types of materials, that is, sorry, not different types of materials, there are different types of conductors, right? Copper, aluminum, like that. So first thing is material of the conductor, and the next thing is its length, okay, that is the length of the conductor or length of the wire. And the next thing is cross sectional area, right? Sometimes you can see a bulk conductor and sometimes you can see a thin conductor also. So the cross sectional area also plays a main role. Apart from these three parameters, the temperature also plays a main role, right? So resistance of a conductor depends upon all these parameters. So regarding formula, it is given by R is equal to rho L by A, right? L is nothing but length of the conductor, A is the cross sectional area, and here the rho is known as resistivity of the material, right? So this is the basic formula to represent the resistance in related to resistivity, right? So here comes the end of this video. If you have any doubt, let me know in the comment section. Thank you.